Hello and welcome to Unit 8. This is our second last unit of this course. So hang in there, we're almost done. The end is in sight. So I just want to encourage you to keep going strong. Let's finish strong this course. It's been quite the term, but you're doing well. Keep up the good work, the good effort. Like I said, just know that all the time and effort you're putting in now will pay off next year and will give you strong foundations to make grade 12 pre-cal easier for you next year. Okay, so our Unit 8, or second last unit, is called Inequalities. Just a warning, we're back to long units. This is now a 4-lesson unit. We just came through my 2-lesson unit, so 4 lessons, but still pretty short. And inequalities, we haven't talked about inequalities yet, but you do know about linear and quadratic functions. So we know how to draw a line in a parabola. We learned how to draw lines last year in grade 10. We learned how to draw parabolas in February of this course. Last unit, systems, we had review about how to draw our lines and parabolas. And now we take that knowledge and apply them to graphing linear and quadratic inequalities. So we know about linear quadratic functions. We're now looking at linear and quadratic inequalities. Today we'll just look at linear inequalities. So before we talk about linear inequalities, let's go back and learn and remind ourselves about linear equations. So back in grade 10 math, we spent at least a month, maybe a month and a half on linear relations, linear equations. So we do know the general formula for a line is ax plus by plus c equals 0. That is general form. We also learned how to work with slope-intercept form and point-slope formula back in grade 10. So you should know how to draw a line using any one of those methods. And at this point, we don't specify the method. I'm just assuming you know how to draw a line, and yeah, I assume you know how to draw a line. That should be pretty easy for us at this point. Okay, that's a linear equation, but that's not our topic. We're not looking at linear equations. We're looking at linear inequalities. So if a linear equation is when ax plus by plus c equals to 0, what's a linear inequality? We have 4 types of linear inequalities. Sometimes instead of being equal to 0, sometimes it could be less than 0. Or sometimes it could be greater than 0. Okay, well those are only 2 options. I said there's 4. If it's not equal to 0, it could be less and greater than 0. What's left? Well, sometimes it could be less than or equal to 0, or it could be greater than or equal to 0. So those are our 4 different types of linear inequalities. It could be less than 0, greater than 0, less than or equal to 0, or less than or equal to 0. So those are the 4 types of linear inequalities. When we look at quadratic inequalities, those will be the same 4 scenarios. Less than 0, greater than 0, less than or equal to 0, less than or greater than or equal to 0. Okay, so that's just our definition of inequalities. I know you've worked with inequality signs in previous math years, so that should not be brand new symbols for us. I know sometimes people get the symbols mixed up, but hopefully we're good with those. Okay, so my famous phrase of the day, there's really nothing new that we're doing here today. It's all concepts we've learned in previous math years. So today we're just going to be graphing linear inequalities. So there are 2 different methods, and I did list both of them in your notes. I'm only going to show you method 2, but I still left both in your notes. I like to give you the full picture, and technically you can use whichever method you want to use. But I find method 2 is a little bit easier, a little bit straightforward, and connects more to what we did last year in grade 10 math. So if you're using method 2, you do have to get your initial inequality into slope-intercept form. Now I know I'm putting an equal sign, but it's not equals, it's inequalities. I know that, I didn't make a mistake, but we're just going to start with putting it into slope-intercept form. So hopefully we remember from grade 10 math, once you have it into slope-intercept form, the m value, that represents our slope, and the b represents where you have the y-intercept. That was all grade 10 math. Okay, so once it's into slope-intercept form, then you can analyze the inequality sign. So step 1 is we get it to slope-intercept form. We graph the line using slope-intercept form. If you forgot how to do that, reread your grade 10 notes because we spent a month and a half last year going through that. Then once you have your line, there's 2 different ways we can draw our line. Sometimes it's a solid line and sometimes it's broken. It's not broken as in asymptotes. That's a different kind of broken line. This is our actual inequality. How do we know if it's solid or how do we know if it's broken? Well, we look at the inequality sign. If it's greater than or equal to or less than or equal to, if you see that sign underneath, then that's a solid line because that means the points are included. If you just see greater than or less than with none of that equal to line underneath, then you'd use a broken or dashed line because that means the points are not included. Okay, so that's grade 10 math. This is maybe the new part here. You just have to consider, am I drawing a solid or broken line? And then the third one is shading. Because there's multiple solutions to these. When we solved our systems unit last time, when we had, or even last year when you have two lines, a line and a parabola, two parabolas, you can have 0, 1, 2, infinite solutions. Well, this is different, right? We're not looking for where they intersect. We're only dealing with one function or inequality at a time. It's not like our systems where we have two at a time where we're looking for the intersection points. We're looking for which values satisfy that inequality. So there's going to be many answers that are included. So how do we show which answers we include? We shade. We either shade above or we shade below the line that we drew in step 2. How do we know? If you're using method 2, if you have it in slope-intercept form, if your y value is greater than or greater than equal to, then you would shade above. That makes sense. Y is greater than, shade above. If you have it less than or equal to, you shade below. Makes sense. If y is less than, you shade below. If y is greater than, shade above. This is the method I use. I know teachers use different ones. You can use method 1 if you want, by all means. We should all get to the same answer at the same point. I think this one's a little bit easier. Like I said, it connects more to what we did last year in grade 10 math. Okay, so we're going to do 2 examples together. Actually, my first example is probably the harder of the 2 examples, so that's okay. It'll just make example 2 seem easier. So 4x minus 3y less than or equal to negative 12. I know you're at home and I can't see whether or not you're using technology, so if you type this into Desmos, you'll get the answer right away, and that will be easy, but that doesn't really show that you understand the steps involved. So I do encourage you to try these by hand at first, and then you can go to Desmos and to compare your answers. But again, just a heads up, if you're taking grade 12 pre-cal, we are not allowed to use any graphing calculators in grade 12. All the graphing in grade 12 is done by hand without technology. So I'm looking ahead in the future for you. And then if you go into calculus, no calculators at all. So I'm looking 2 years ahead to prepare you. So yes, maybe life is harder now, but that should make it easier for you in the future. Okay, so 4x minus 3y is less than or equal to negative 12. First, we have to get it into slope-intercept form. So I treat this inequality like it's an equal sign. I don't write it as an equal sign. Just to get rid of the 4x, I would subtract both sides by 4x. Now, to get it into slope-intercept form, I can't have a negative 3 here. So to get rid of the negative 3, I have to divide each term by negative 3. But I do have this rule here. You should have learned this rule somewhere previously in math. If you divide or multiply both sides by a negative value, that changes the sign direction. If it's positive, you leave it as it is. But if you're dividing out by negative, you have to change the sign. So in my next step, negative 3 divided by negative 3 is positive 1, but I'd have to flip this sign around because I divided by a negative. It's a very easy step to forget with everything else going on, okay? Then I have a fraction, that's okay. Oh, I have a fraction, that's okay. I don't need to reduce it, but I should recognize a negative divided by negative is a positive, and negative 12 divided by negative 3 is plus 4. There you go. So that's my slope-intercept form. It doesn't matter if you have the x line or there or not. That's okay. Either one is fine. That's not a communication error. That's fine. But I think we're more used to seeing it like that. Okay. So we are ready to graph. So slope-intercept form. We should know how to graph from grade 10 math. We start with the intercept. The intercept is at 4. 1, 2, 3, 4. So my first point is there at 4. Then I use the slope to get my second point. So from that point, slope is rise over run. So from this point, I go up 4, right 3, and then I connect them, and then that's my line. Except, is this going to be a solid? Is this going to be a dashed line? We'll have to check here. This says it's less than or equal to. So because it's equal to, I connect them, hopefully with a ruler, not freehand like I'm doing, with a solid line. So I'm using a solid because it was less than or equal to. Now here's the fun part. Where am I shading? Because remember, there's going to be multiple points on this graph that satisfy that equation. So which xy values make that true? So which step do I use? Do I use here? No, it's once it's in slope-intercept form, this is where I decide whether I shade above or below. So it says y is greater than or equal to, so I will shade above. Now it's, I usually say, it's not an art class, but it's not kindergarten class. So for shading, I'm fine if you do shading like this. Some teachers might expect a little bit more, but for me, that's enough for shading. And in terms of a scale, I had a scale there. There we have our scale x, y. My line is solid, and I shade above. There you go. That's our first linear inequality. And that's probably one of the toughest one we have because we had to manipulate and move around that negative value. Let's do one more example, and then I think you'll be ready to try some on your own. So our second and final example, 2x plus 3y is less than 5. Again, if we're using method 2, step number 1 is we have to get it into slope-intercept form. Again, it's the same way you would just treat the inequality like it's an equal sign. So subtract out the 2x. Again, I have a number in front of the y. I need to get rid of it, so I'm dividing everything by 3. But there's no need to flip the sign around because I divided out by a positive 3, not by a negative, so I don't change the sign. And there you go. Well, that was easier. Oh, but look, now we have to graph fractions. How do we graph fractions? Very carefully. So again, this is slope-intercept form. We know this from grade 10 math. We start by plotting the intercept, which is 5/3, which is, oh gosh, oh, exactly right there, 5/3. Actually, it's a little bit lower. Okay, I'll just make my scale where we're, like I said, the fun part is graphing fractions. Okay, so that would just be 1 and a bit. So there you go, exactly, 5/3. That's my first point. Then from this point, we have a negative slope. So that means we are going to go down 2 units, right 3 units. So that's where my second point is. I'll just do this 3. Oh, perfect scale. Now, we've got our 2 points. Are we connecting them with a solid or a dotted line? Well, let's look. It's less than. It's not less than or equal to. It's just less than. So we connect them, but with a broken or dashed line. It's not less than or equal to. We're not including the points in the actual line. It's always less than that line. Okay, and then the final step. Which way are we shading, above or below? Well, we are shading below. Y is less than, so there you go. I'm shading below. So this means any value you choose from this region, if you take any point in this region and plug it in, it would satisfy that equation. It would make that statement true. So let's just do a test. For verifying, we don't have to use a t-chart anymore. We can just look at the graph. Well, actually, let's try it both ways. The test point 0, 0. Does the test point 0, 0 satisfy this equation? Well, let's look. Where's 0, 0? Right here. It's in the shaded region. So yes, 0, 0 would be a solution to our inequality. I can see that right off of the graph. Or if I had to test it without, again, I would replace. We're not using t-charts for this one because we've got that inequality. We have 0, 0. Is 0 less than 5? Yes, that statement is true. So that's 2 ways to verify your solution, but only do that if they ask you to or if I ask you to in the notes. Okay, so there you go. If you know how to draw a line in slope-intercept form, then the only new part is deciding whether it's solid or broken and if we shade above or below. Okay, good luck and have fun, and tomorrow we'll be doing a very similar topic but with quadratic inequalities.